Hey everyone, welcome to this explainer. If you've ever stopped to wonder exactly how the digital world ticking away around us actually operates, well, you are in the perfect place. Today we're going on a really fascinating journey to demystify C programming. I want you to think of this explainer not just as a lesson in coding, but as learning how to build a magnificent, incredibly sturdy house from the ground up using the foundational language of modern software. We're going to act as the architects, the builders, and the engineers all rolled into one. So get ready, because you're about to understand the true blueprint of code.
So here's how we're going to build our understanding today. We'll start by meeting the C language itself, then we'll map out the blueprint of code. After that, we'll go over the strict rules of construction, dive into our data types, and finally, we'll bring our code to life. Let's just jump right in.
All right, phase one, meet the C language. Before we pour any concrete or, put up the walls, we really need to understand exactly where our tools came from and why they matter so much to the entire world of software.
Okay, let's dive into this. C didn't just magically appear out of nowhere, right? It was actually developed by a brilliant computer scientist named Dennis Ritchie way back in 1972 at Bell Labs. But it wasn't the very first of its kind. It's an evolution. It actually evolved from a lineage of older foundational languages, specifically ALGOL, BCPL, and a language literally just called B. Ritchie basically took the absolute best concepts from those predecessors and engineered something completely revolutionary, and honestly, it's still running heavily under a massive variety of operating systems today.
So what actually defines this language? Well, its absolute superpower is its machine independence. It lets developers write software without constantly agonizing over the specific hardware platforms where those programs are eventually going to run. Whether you're building a massive system package or just a business app, C is astonishingly fast, efficient, and highly portable. You write it once, and you can take that blueprint almost anywhere.
Moving on to phase two, the blueprint of code. We've got our history and our context. Now, just like every physical house needs a roof, walls, and a solid foundation, every single C program relies on a non-negotiable structural layout. Think of this overall structure literally like a house's blueprint. Right at the very top, we have the Include Header Files section. You can picture header files like prepackaged toolboxes, things like standard input and output functions that you just bring onto the construction site so you don't have to reinvent the wheel every time. Right below that is the Global Declaration section. These are like community resources, say a central water line, that are totally available to every single room in the house. Then we've got our main function, and finally, user-defined functions. Those are basically specialized rooms or additions you design yourself to handle specific tasks, and you can define those either before or after your main function.
Now, before we actually go inside, let's talk about the notes scribbled on our blueprint. In C, we write comments by wrapping text in a slash and an asterisk. And listen, comments are absolutely vital for human readers. They're basically like little sticky notes left on the blueprint for other builders, just explaining the flow of the program or maybe why a certain design decision was made. But here's the real magic trick. The computer's compiler completely ignores them. No way, right? They literally do not affect your program's execution at all. They are purely there for documentation and clarity. Okay, so now we arrive at the absolute core, the main function. If a C program is a house, the main function is the front door. Every single C program in the entire world absolutely must have a main function, because this is the exact starting point where execution begins. The whole interior of the house, both the declaration part and the executable part, is entirely contained within an opening curly brace and a closing curly brace. Simply put, if you aren't inside those braces, you aren't inside the house.
All right, phase three, rules of construction. Now that our blueprint is drafted, we need to talk about how we actually build the thing. Computers are incredibly literal machines. If we want them to build our house correctly, we have to communicate using strict, non-negotiable syntax. You really have to follow the code of construction here. First up, generally write all your statements in lowercase letters. Uppercase is usually reserved for symbolic constants. Second, you can totally format your code with blank spaces between words just to make it readable, but never ever stick a space in the middle of a variable name. Third, every time you open a curly brace, you must close it. They literally have to be perfectly balanced. And finally, the crucial point is the semicolon. Just like a period ends a sentence in English, a semicolon separates and terminates statements in C. If you forget it, the compiler gets incredibly confused and all construction just halts.
Now, while you're building, you're going to need to label your materials. We call these labels identifiers or variables.
You actually have a lot of freedom here. You can use sequences of letters, digits, and underscores, so things like John, value, or total are completely fine. But there are some strict bans. You absolutely cannot start a variable name with a number. You can't use special characters like parentheses, and most importantly, you cannot use reserved system keywords like char or int. Oh, and just a quick aside, remember that only the first 31 characters are significant to the compiler, and uppercase is treated completely differently than lowercase.
Moving right along to Phase 4, data types. So we know the rules, but what are we actually building with? Think of data types as the raw physical materials, like the wood, the glass, the bricks, the steel, that are actually going to make up our functional code.
And this brilliantly illustrates exactly what we have to work with. When you declare a variable in your warehouse, you have to tell the computer exactly what kind of material it is so it can allocate the right amount of space. An int is for whole integer numbers, typically taking up a 16 or 32-bit word of space. A char is for single characters, and it's much lighter, usually stored in just 8 bits. We use float and double for numbers with decimal points. And void, well, that's a unique generic type that explicitly tells the program, hey, this returns no value. Ultimately, your choice of material dictates exactly what kind of data your house can hold.
All right, final phase, bringing code to life. We have our history, our blueprint, our syntax rules, and our raw materials. Now for the absolute most exciting part. Let's actually step into the finished room and see how the blueprint we've written turns into a living, working program.
Turning human-readable text into a machine-executed action actually happens in 3 distinct chronological steps. First up is the creation of the program, where you, the programmer, type out the syntax and the logic. Second is compilation and linking. This is where the computer translates your high-level, human-readable instructions into the binary ones and zeros the machine hardware actually understands, while simultaneously linking in any of those header file tools you requested. And finally, execution. The computer runs those translated instructions, providing you with your useful output.
Let's move to and see how this builds with a classic Hello World program. Right at the top, we import our toolbox with standard input-output. Next, we open the front door with our int main function and an opening curly brace. Inside, we give a single instruction. Print the words, "Hello World, I am new to C," directly to the screen. We terminate that instruction with our crucial semicolon. Then we just return 0, close the brace, and boom, our house is successfully built.
So you've just learned the foundational architecture of literally one of the most important programming languages in human history. You know how to structure the blueprint, you know the strict rules of the construction site, and you know how to select the right raw data materials. But honestly, all of this knowledge is just potential energy waiting to be unleashed. The real magic happens when you sit down and start writing your own code. So I'll leave you with this final thought. Now that you hold the exact blueprint to the digital world, what are you going to build with C? Get out there and start coding.